Good evening, children. Welcome to Akshara IIT classes. This is Srinivas, your maths faculty. Welcome to today's class. Right. So in our previous classes, we have discussed about that congruence rule, right? Congruence rule. That means A, B and N, three integers. We can write the three integers in the form of A is congruent to B modulo N. If it is possible, only A minus B is divided by N. A minus B is divided by N. Okay, let us go to this. Right. So let A, B and N are integers, whether they can be positive or negative. Here the condition is given, N is greater than 0. That means all three must be positive integers. That means A, B, N. These three integers must be positive, and we can write the integers is in the form of A congruent to B modulo N. It is only possible that N divides A minus B. N divides A minus B, or we can write in another way also, A minus B is divided by N. N divides A minus B, or A minus B is divided by N, where A, B and N are positive integers. Clear? We have discussed some examples on it also, and some of the properties we discussed in our previous class. What are the? If A congruent B modulo N is three set of integers, same way C congruent D modulo N, A congruent B modulo N and C congruent D modulo N. Like three different set of integers we have taken, and when we add both of them, we will get the first property. That means we are just adding the LHS part. A plus C is congruent to B plus D modulo N. Here first one and second one should be divided by N only, modulo N. Okay. Same way we can apply minus symbol also. That means A minus C is congruent to B minus D modulo N. In same way, A into C is congruent to B into D modulo N. These are the first three properties of congruence. Now check fourth one also we have discussed. P and Q are any integers. P and Q are any integers. Then we can write PA plus QC equals to PB plus QD. That means the first set of integers multiply with P. That is nothing but PA is congruent to PB modulo N, where P can be any integer. In same way, the second set of integers multiply with Q. QC is congruent to second one, A is congruent to B modulo, I am writing once again, B modulo N, where A, B, N are three positive integers. Same way, C is congruent to D modulo N. Okay. From this first set of integers, if you multiply both sides with P, it will be PA is congruent to PB modulo N, and where P can be any integer. Same way, QC is congruent to QD modulo N. When you add these two also, we will get PA plus QC that means left hand side parts, PA plus QC is congruent to PB plus QD modulo N. This is congruence rule, right? Next, same way, f of A is congruent to f of B modulo N, where f is any polynomial. F is any polynomial, whether it can be linear, quadratic, cubic polynomial or biquadratic polynomial. It can be any polynomial. It is also satisfied with the integers of coefficients. With integer coefficients. Okay? Same way, A congruent B modulo N. Just I am multiplying with x. Like P, how I am multiplying, P can be any integer. Same way here also, x can be any integer. A into x equal to B into x modulo N. Okay na? Same way division. First we have taken two different set of integers like A, B, and they are written in the form of A is congruent to B modulo N. Same way C is congruent to D modulo N. We are applying the arithmetical operations between them, addition, subtraction, multiplication. Okay. Next, with the integers, we are taking an integer q or x. If you multiply ax equal to bx modulo n, a by x equals to, or a by x is congruent to b by x modulo n. Okay na? This is about congruent rule. Clear until then? Right. Let us see that Fermat's theorem. Let us see the Fermat's theorem. If P is a prime number, P is a prime number and A is any number, A can be any number, then we should write A power P minus 1 is congruent to 1 modulo P. A power P minus 1 is congruent to 1 modulo P. Here P is nothing but from the set of prime numbers. P is from the set of prime numbers, and you have to identify that A and P having a common factor 1. That means A and P must be co-primes or relatively prime numbers. Here see here, A comma P equals to 1, it is nothing but, it is clearly indicates that the HCF of A and P, highest common factor between A and P equals to 1. Whenever we write like this, any two numbers in the brackets, that gives 1. That means the HCF, that means highest common factor between these two numbers is 1. Simply we can say that they must be co-primes or relatively prime numbers. They must be co-primes or relatively prime numbers. Obviously co-primes or relatively prime numbers will be, because P can be any prime number because it does not have any common factor with remaining. But there is one more chance here. For example, if you take P value is 5, A value is 15. There is a common factor between them is 5. Am I right? P will come in 5 table, A also will come in 5 table. That means 5 is come in 5 table, 15 also come in 5 table. In these situations, it is not work out. That's why he is clearly given the condition between those two numbers is 1. That means they must be co-primes or relatively prime numbers. Okay na? Now let us take that. I am taking one example. 4 power 3 minus 1 is congruent to 1 modulo 3. 1 modulo 3. Check here, is it satisfying or not? 4 power 3 minus 1. 3 minus 1 means 2. 3 minus 1 means 2. So 4 power 2. 4 power 2 means 16. 4 power 2 means 16. Simply 16 is congruent to 1 modulo 3. 16 is congruent to 1 modulo 3. That means, is it satisfying the congruent rule or not? We should check. What is the congruent rule? If A is congruent to B modulo n, if A is congruent to B modulo n divides A minus B. Am I right? N divides A minus B. Here n means what? 3. 3 divides 16 minus 1 or not? 3 divides 16 minus 1. 16 minus 1 is 15. Yes, obviously 15 is a multiple of 3. So 3 divides 16 minus 1. So even though we are taking as a Fermat theorem, it should be satisfies the congruence rule also. Because finally we are writing or we are expressing this Fermat's theorem in the form of congruence. Okay na? And we can write Fermat's theorem in another way also. That is, instead of A power P minus 1 is congruent to 1 modulo P, we can write this one, A power P is congruent to A modulo P. A power P is congruent to A modulo P. Both are same. Can you identify the difference between them? Check. For example, okay. See here, how I am writing the first format into the next one. That means A power P is congruent to A modulo P. Here A power P minus 1. Here I did not write 1. Where the 1 has gone? So simply according to the laws of exponents, A power m by A power n is nothing but A power m minus n. Am I right? In same way, I can write A power P minus 1, I can write as A power P by A power 1. A power m by A power n is nothing but A power m minus n. Same way, A power m minus 1 we can express it as A power m by A power n. Same formula is congruent to 1 modulo P. A power 1 is nothing but A only. A power 1 means A. It is dividing, when you transpose it is multiplies. So 1 into A is A. Like this it can. Okay na? Just you simply remember this one. A power P is congruent to A modulo P, where A value, P value must be co-primes. That means there is no common factor between them. And here also A. That means both are same values. For example, if I give that 4 power 3 is congruent to x into modulo 3. What is the value of x? Compare these two. A power P is congruent to A modulo P. Here P, here also P, modulo P. Same way, 4 cube is congruent to x modulo 3. Very good. So, x is nothing but 4. X is nothing but 4. Clear? Right. Factorial n. Factorial n is nothing but factorial n means the product of first n natural numbers. Product of first n natural numbers. See. Product of first n natural numbers is called factorial n. So we can write factorial n. This symbol we can pronounce as factorial n, or this one we can write as n factorial. This is also factorial. Looking like exclamatory symbol, right? Yeah, factorial n or n factorial, both are same. We can write in any way. So n factorial means what? Product of first n natural numbers. first n natural numbers. For example, 5 factorial means product of first 5 natural numbers. First 5 natural numbers are 1, 2, 3, 4, 5. That means 1 into 2 into 3 into 4 into 5. 5 factorial means first 5 natural numbers we need to multiply. That means product of first 5 natural numbers. 10 factorial, product of first 10 natural numbers. N factorial, product of first n natural numbers. Clear? Right. Now here you need to remember that, for example, 6 factorial is there. This 6 factorial I can write as in reverse order, descending order. Actually 5 factorial means product of first 5 natural numbers. 6 factorial means product of first 6 natural numbers. So the production we can do in any way, right? Like a commutative property, A into B or B into A, both are same. Same way I can write in decreasing order, right? Six factorial means 6 into 5 into 4 into 3 into 1. Now again this one I can write as 6 into, can I write this one 5 factorial up to here? Am I? Yes. 5 factorial means product of first 5 natural numbers. Or 6 into 5 into 4 factorial also we can write. 6 into 5 into 4 factorial, or 6 into 5 into 4 into 3 factorial. This is nothing but 6 factorial only. 6 factorial only we are expressing in this way. Same way, how can we write n factorial? N into, n before, very good, n minus 1 factorial. N factorial is nothing but n into n minus 1 factorial. Same like 6 factorial means 6 into 5 is nothing but 6 minus 1. 6 into 6 minus 1, 5. 6 into 5 factorial. Same way n factorial we can write as n into n minus 1 factorial. It is very, very important. That's why I have explained this. For example, if n value 0, if n value 0, now substitute here in the place of n, 0 factorial equal to 0 into 0 minus 1 factorial. Am I right? Can I write like this? Yeah, but I am just changing in such a way, I am taking n value 1 instead of 0. I am taking n value 1 instead of 0. Now substitute 1 factorial. 1 factorial means first 1 natural numbers, only 1. 1 factorial value 1. Right, I am writing. 1 factorial value is 1. 2 factorial value 2 into 1, 2. 3 factorial value 3 into 2 into 1, 6. 4 factorial value 4 into 3 into 2 into 1, 24, like. So 1 factorial value 1. What about 0 factorial? 0 factorial value? 0 factorial value also 1. How 0 factorial value 1? See here. From this, I am substituting n value 1. So in the place of LHS, in the place of n, I can write 1. So 1 factorial equal to 1 into 1 minus 1. 1 minus 1. 1 minus 1 means 0. So 1 into 0 factorial is 0 factorial is 1. So 0 factorial value is 1. Same way 1 factorial value is also 1. Okay na? So simply factorial n or factorial 3 or 3 factorial, 5 factorial, 6 factorial, whatever. Factorial means product of first n natural numbers. Product of first n natural numbers. 6 factorial, product of first 6 natural numbers. 100 factorial, product of first 100 natural numbers. Clear? That is about factorial n. Okay na? So today we have discussed two congruence properties. Fermat's theorem. What is Fermat's theorem? A power p is congruent to a modulo p, or a power p minus 1 is congruent to 1 modulo p. Their relation is a and p are co-primes. Nothing but HCF of a and p is 1. HCF of a and p is 1. Clear? Very good. Now please note it if you want. Next. Yeah, Wilson theorem. So many theorems. So these are helpful to solve the exercise problems. Okay. So Wilson theorem is nothing but p minus 1 factorial plus 1, p minus 1 factorial plus 1, this one, p minus 1 factorial plus 1 is divided by p, is divided by p, where p is a prime number. So simply, if p belongs to set of primes, p belongs to set of prime numbers, p minus 1 factorial plus 1 definitely divisible by p, is definitely divisible by p. Let us check through one example. See, if p equals to 5, p equals to 5, 5 is a prime number or not? Yes, 5 is a prime number. Substitute in Wilson theorem, this one, 5 minus 1 factorial, 5 minus 1 factorial plus 1, 5 minus 1 factorial plus 1. 5 minus 1 value 4, 4 factorial means, 4 factorial means product of first 4 natural numbers. That means 4 into 3 into 2 into 1, 24. 4 factorial value 24. 24 plus 1, 25. Yes, 25 is divisible by 5 or not? Yes, obviously. 25 is divisible by 5. That is the Fermat's theorem. If any prime number, if you express it in the form of p minus 1 factorial plus 1, that answer is exactly divisible by that prime number. That answer is exactly divisible by that prime number. Okay na? Now let us check, is it possible for every prime number or not? Is it possible for every prime number or not? Now I am taking one more prime number, that is p value 7. P value 7. Write the Wilson theorem. What is the p value? 7. So Wilson theorem is p minus 1 factorial plus 1 should be divisible by p. Let us find p minus 1 factorial plus 1 value. In the place of p, I have to substitute 7. Yeah, 7 minus 1, 6 factorial. 7 minus 1 is 6 factorial. Yeah, just tell me the 6 factorial value. 720. See, product of first 6 numbers, 1 into 2 into 3 into 4 into 5 into 6, up to 6, we will get how much answer? 720. Just 6 numbers we got the answer 720. 720 plus 1, it is 721. 721 is divisible by 7. Yes, obviously 721 is divisible by 7 103 times. It is possible for every prime number. Please notice, children. Okay, children? Right. Yeah, test of divisibility, nothing but divisibility rules. So let us discuss the divisibility rules for 2, 3, 4, 5, 6, 8, 9, 10, 11, 25. Let us discuss the divisibility rules of these numbers. That means if you see any one of the number, is it divisible by the respective numbers or not, we need to check. Clear? Yeah. Now divisibility of rule. What is the divisibility rule? Rule for 2. If a number is divisible by 2, its unit digit is 0 or even number. Its unit digit is 0 or even number, then the entire number is divisible by 2. What is that? Units digit is 0 or even number. Next, for example, if you take like this, see that unit digit means last digit, ending digit, this one. Last digit is even number or odd number? 3 is odd number. So the entire number is not divisible by 2, because what is the rule for 2? It should be divisible by 2 means it should be end with even or 0, even number or 0. That means same number. Now this entire number will be divisible by 2 because units digit is even. Units digit is even. Clear? That is the divisibility rule for 2. Same way, now I am going to explain about the divisibility rule for 5. Let me discuss about divisibility rule for 5, because these are all somewhat similar. Same. Here divisibility rule for 5, the units digit of a number is 0 or 5. The units digit of a number is 0 or 5. Then the entire number will be divisible by 5. And the entire number will be divisible by 5. I hope you know all of these. Yes, check the last digit or unit digit is 0. So we can say that this number will be divisible by 5 because it is ending with 0 or 5. Same way rule 10. This is also units digit of a number is 0. Unit digit of a number is 0, then the entire number will be divisible by 10. Okay, now see rule 2, rule 5, rule 10, we just discussing about with the combination of unit digits. All are ends with zeros. Am I right? If unit digit is ended with 0, it will be divisible by 2, divisible by 5, as well as divisible by 10. And some more extra for rule 2 is 0 are even numbers. Even numbers means 2, 4, 6, 8 like that. Okay, na? Same way 5 means 0 or 5. Rule 10 only 0 is enough. Okay, na? These are all we are discussing based on units digit. Based on units digit. Yeah, please note it. Right. So we completed rule 2, rule 5 and rule 10. 3 numbers completed. Now 3 and 9 having same way. We are expressing rule 3 and rule 9 in a same way. Okay, na? What are the rule 3 and rule 9? Rule 3 is simply sum of the digits of a number. Sum of the digits of a number is multiple of 3. Sum of the digits of a number is multiple of a 3. I am writing here, sum of its digits is multiple of 3. For example, 3, 6, 3, 9, 3, 5, 2, 2. For example, this is a very lengthy number, right? Now, before going to direct division, let us check this number will be divisible by 3 table or not. How to check? By adding its digits. Sum of digits means adding its digits. Check 3 plus 6, 9, 9 plus 3, 12, 12 plus 9, 21, 24, 29, 29 plus 2, 31, 31 plus 2, 33. The sum of the digits is 33. So from this we can say that 33 will come in 3 table directly. So we can say that the entire number will be divisible by 3. Entire number will be divisible by 3. Now say that I told you rule 3 and rule 9 having a same condition. Can you say that rule 9? Come on. Yes. Sum of digits is very good. Multiple of 9, because we have to check 9 table now. So sum of digits is multiple of 9. That means same number if you observe, the sum of digits is what? 33. 33 will come in 9 table? No. So this number is not able to divisible by 9. But it is divisible by 3, not indivisible by 9. Clear? What is rule 9? Same like rule 3. Rule 9 is sum of its digits. Sum of its digit is multiple of, very good, multiple of 9. Clear, children? Yeah, until then you have learned 5 rules. Rule 2, Rule 4, Rule 10 and Rule 3 and Rule 9. 2, 4, 10 we are discussing based on its unit digit. 3 and 9 discussing based on sum of its digits. Sum of its digit. Clear until then? Good. Next, still we should discuss 4, 8, 25. 4, 8, 25, these are somewhat related. Okay, na? Rule 4 I am discussing. Last 2 digits of a number. Last 2 digits of a number. That means units place digit and tens place digit. I am writing here last 2 digits. In the sense, that means units place or ones place, we can call units place or ones place, both are same. Units and tens place digit. So last 2 digits are zeros. Both digits must be zeros or multiple of 4. Multiple of 4. Multiple of 4 means 4, 8, 12, 16, okay, 20, 24 like that. Last 2 digits, 4 means 0, 4 it should come. Last 2 digits. 4 multiple means 0, 4, 0, 8, 12, 16, 20, 24. Last 2 digits. Or both are zeros also. The entire number will be divisible by 4. This entire number will be divisible by 4. Whatever the first numbers, it doesn't matter. The number exactly divisible by 4 table if the 2 digits containing zeros are multiples of 4. Zeros are multiples of 4. Okay, na? all are divisible by 4 based on this rule. Okay. Same way, what is rule 25? Rule 25 also same. Last two digits of any number, zeros are, tell me that, zeros are, what is here? Multiple of 4. Here? Very good. Multiple of 25. Multiple of 25 are just, I can check, 25, 50, 75. Again 100, 2 zeros come. Next multiple 125. Last 2 digits, again 25 will come. Same repeated. Last 2 digits, zeros are multiples of 25. Then entire number will be divisible by 25 table. Okay na? Good. Now last but not least, rule 8. Why I am discussing about rule 4 and rule 25 together instead of 8 between? Because we just checking these two for last 2 digits only, but rule 8 we have to check for last 3 digits. How many? Last 3 digits. That means ones place, tens place and hundreds place also. Last 3 digits same. Zeros are multiple of, very good children, multiple of 8. Then the entire number will be divisible by 8. Now your task is just write some examples based on these divisibility rules. Okay na? So we have discussed 2, 5, 10. Next 3 and 9, 4, 25 and 8. Clear? Just learn accordingly, you will get it. Yeah, thank you one and all. Have a nice day. We'll discuss in further class.